Okay, so the first problem we're going to do is to find the height, find the volume of this oblique or slanted, oblique means slanted, prism. The first thing you have to notice is that the two sides, the 4 and the 8, are parallel, and so we can use the formula for the trapezoid, which says you take half the sum of the bases. So that'll be 4 plus 8 divided by 2, and then you multiply that by the height, which is 9, and then that's the area of each of the bases, and then you multiply that by the height, which is 15, and you get 810 centimeters cubed. Now in the problem in the book, it just says that it's a slanted, it gives the same kind of sizes, I guess is what I wanted to say. All right, for this one, this is like number 3, I believe. Let me check. The volume of a triangular prism, 695. Yeah, so in this case, and in the case in your book, you have to use Hero's theorem first of all. So it would be a good idea to get all of those measurements down. Remember, Hero's theorem starts out with the semi-perimeter, so that's 4.5 plus 9.0 plus 7.2, and then you would add that up and divide it by 2. So 4.5 plus 9 plus 7.2 over 2, and so the semi-perimeter is 10.35. Okay, so then we would take that and use Hero's theorem to get the area of the base. So we would take square root of the semi-perimeter, 10.35, times the semi-perimeter minus each of the 3 sides. 4.5 times 10.35 minus 9 times 10.35 minus 7.2. And so the area of each base is 16.046. That's the area of each base. And then you multiply that by the slant height, 8.1, to get the volume. So times 8.1, and the volume will be about 130 centimeters cubed. Well, yeah, centimeters cubed. Next one is, this one, which is like number 4B, find the lateral area and total area and volume. So we've got all 3 of those things to find for this rectangular prism. Lateral area, total area, volume. Now the lateral area doesn't include the the lateral area doesn't include the 2 ends. So it's 34 by 170, but there are 3 of them. The total area also includes the ends, so it's the lateral area plus you could use Hero's theorem, or just note that the height here is, well, if this is 17, This is 17 root 3 is the height. So plus 17 root 3 times 34, but remember it's 1/2. And then the volume will be this area here times 170 will be the volume. Okay, so let's do the math and let's write each of those in. So the lateral area is 34 times 170 times 3, and we get 17,340. The base of the triangle is 17 square root 3 times 34 over 2 is 500.56. And the volume is that times the height, 170. Now I'm going to go back, so the volume is 85,095 millimeters cubed. I just got to make sure I got that right. 96 millimeters cubed. Okay, let's get the right number of sig figs. Looks like we've got 2 sig digs is all we can have in our answer. So the first one, we would write that answer as 17,000 millimeters squared. 17,300 plus 500 is 17,840 millimeters squared, but we can only have 2 sig digs, so we would say 18,000 millimeters squared. And then finally for our volume, we can have 2 sig digs, so we would say 85,000 millimeters cubed. Next one. We're supposed to find the area of the shingled surface and the volume enclosed by the roof. Okay, so in this particular case, we first of all need to get the length of the hypotenuse. Since it's 33 all the way across, it'll be square root, sorry about that, square root 33 over 2 squared plus the height is 11 squared. So the length of the hypotenuse is 19.830 times 36 means that each of those 2 roofs has an area of 714. So since there's 2 of them, we would say the shingled area is 1,428 feet squared, which would be 14 squares of shingles. Well, we better get 15, otherwise you won't have enough to finish the roof. Then it says, what is the volume of that roof? Well, volume is the area of the base, which is half. Remember, it's 11 times 33 divided by 2, and then you multiply that by the length, which is 36, and you get 650 6,534 cubic feet. Now, right number of sig digs looks like 2 in each case. So we would say 1,400 there, and we would say 6,500 cubic feet there. Next one. This is like number what is that? Number 6100, which is, I just did it. Where is it? Oh, number 8. So it says find the lateral area, total area, and volume of this figure. So lateral area, total area, volume. In this case, this is the top and the bottom. So the lateral area will be the 5 by 2, but there's 2 of them, plus the front 10 by 2, but there's 2 of them, and so the lateral area is 60. The total area, we're going to add to that the area of the top, which is 5 by 10, but there's 2 of them, and so that'll be 100, so the total area will be 1,600, or 160, excuse me, and the volume is pretty easy too, 5 times 2 times 10. So the volume is 100 centimeters cubed, centimeters squared, centimeters squared. Next. This is number 9. How did I figure this volume is 391 inches cubed? Well, what I did is I took the side and cubed it. So if I take the cube root of 391, I get each side is 7.31 inches. So if I take 7.31 and square it and multiply that by 6, that'll be all 3 sides, which if you notice I say the surface area is 321. Next one. This is number 11. Okay, so what we're doing is we're grinding off 1/10 of an inch at a time. And this is a square inch, okay? So we're grinding off 0.1 times 1 times 1 each time, or getting 1/10. If we take 0.3 divided by that 0.1, we have to make 3 passes here to grind off that much stuff. Next one, number 12, we're going to fill the tank. We know it's 7 meters wide. We know that if we put 5 meters cubed in, we fill it 5 centimeters. So what we're going to do is take that 5 meters cubed and divide it by 7, and then divide that by, now remember this is in meters, so 0.05, because that's how much 5 centimeters is, and we get 14. So we started with 5 cubic meters, we divided it by 7, and then we divided it by 5 again, and we're down to 14 is how wide this part here is. That's not really true because it's nowhere near that wide. But to solve the problem, you would take the volume divided by the length divided by the depth, and that'll give you how wide that container is. Next one, it says each truck holds 9 cubic yards. We're going to make a road 40 feet long wide and 4 miles long and 4 inches thick. So, and since that's in cubic yards, let's change each of these into yards. So we've got the volume of that road is going to be 40 over 3. That's how wide it is, by 4 over 36, because that's how many yards thick it is, by 4 times 1760, because there's 1760 yards in a mile. So we get 10,429.6 cubic yards of dirt, because here's a yard, here's a yard, here's a yard, and so we've got cubic yards. And each truck holds 9 cubic yards, so we're going to divide that by 9, and we're going to see we need 1,159 loads of gravel. That's a lot of gravel. Next one. Here we're digging a basement, and the basement is 30 feet long, 6 feet deep, and 40 feet wide. So 6 times 9 times, what? Not 9, it's 6 times 30 times 40. So we get 7,200 cubic feet. There are 27 cubic feet in a cubic yard, so it's 800 thirds cubic yards. And since each truck holds 8 cubic yards, we're going to need about 33 truckloads to empty that basement, or to get out of that hole. Next one, how many cubic feet are there in this face cord? I always thought a face cord was 18 inches thick. But anyway, how many cubic feet is this? Well, it's 2 by 4 by 8, or it'll be 64 cubic feet. Next one. How big is this truck bed? Well, to find the volume of the truck bed in cubic feet, we're going to take 66 over 12 by 77 over 12 by 16 over 12. So that's the volume in cubic feet. And then we're going to subtract 2 wheel wells, 2 times 1.2 cubic feet, and we get 44.65 cubic feet. Since each cubic foot can hold there is 100 pounds of sand, so times 100 means that our truck would hold 4,466 pounds, and my truck doesn't. I got sand one time. My truck is only 1,500 pounds. So if we divide that by 1,500, what did I do? Oops. Times 1,500. So since my truck can only hold 1,500 pounds, we can only have about a third of the truck full of sand, and the guy dropped like one corner out of his bucket into the back of the pickup, and it just about bottomed me out. My truck does not. Actually, it's only a half-ton pickup, so it's only supposed to hold 1,000 pounds, but I put more than that in. This is the pyramid question. Find the volume of a, now this says a square-based prism or pyramid. This is not square-based. This pyramid is 7.7 inches wide by 6.8 inches long, and the volume of a pyramid, it says you have to take that times the height So times, now the height is going to be over 3, so I have to get a mixed number here, 3 1/3 inches over 3, because it's the height over 3 times the area of the base, or 1/3 the base times the height, and we get a volume of 58 cubic inches. Oops. Next one. Then it has us doing a slant height problem to find the volume and lateral area of a regular pyramid. Okay, so first off, we have to find the, if this slant height is 5 inches, then, and the whole length is 8 inches, we first of all need to find the height of that triangle. So we're going to take square root of 5 squared, that's the hypotenuse, minus 8 inches all the way across, so it'll only be 4 inches halfway across. And so the height of this triangle is 3. So we're going to take 3 times 8, that's the area of a triangle, but remember you have to divide by 2 to get the area, and there's 4 of them, so the lateral area will be 48. Then it says find the volume of that pyramid, right? Isn't that the next thing what we're supposed to do? Find the volume and lateral area. Okay, so, and then the height we said is 3, so we will take 8 squared times the height, 3, divided by 3, because remember, it's the 1/3 of the base times the height. Last one that it says to do is to find how long this hip rafter is. It says this is like number 33, so it's 12 feet this way, 14 feet that way. So from the middle, this is 7 feet, okay, and 50 feet, let's see. Oh, and then the height here is 6 feet, so we're going to take the square root of 6 times, squared, plus 7 squared plus 6 squared, because you're only going to use half of these lengths and to get the total, and so this oh, I screwed up. Let's see here. Plus plus 6 squared. Okay, so this rafter from here to here is going to be 11 feet. So that's the assignment.